Hello, I'm Abhinav Mishra, and this is my final project for the Programming Machine Learning Applications course at DePaul University. In this project, I developed a movie recommendation system using the Movie Lens 32 million rating dataset. The goal was to predict which movies a user might enjoy based on their previous ratings and preference. Recommender systems like these are used by platforms such as Netflix and Spotify to improve user experiences. So I wanted to build a simplified version of that using real world data. I followed the knowledge discovery in databases process, which includes data cleaning, transformation, visualization, modeling, and evaluation. I used Python, Pandas, NumPy, skitlearn, and Matplotlib to build and evaluate different recommendation models, including user-based collaborative filtering, item-based collaborative filtering, matrix factorization using SVD. In the next few minutes, I'll walk you through the workflow, show how the models were designed and compared, and share the key results and insights. The tools and technologies I used Python with Jupyter Notebook, along with Pandas and NumPy for data manipulation and numerical analysis. I used Matplotlib and Seaborn for visualizations and graphs. I used skitlearn for implementing KNN, K-means, PCI, and SVD. And then I used Sky5 for sparse matrix operations to handle large-scale data efficiently. The dataset which I used for this project is MovieLens 32 million dataset created by Group Lens Research. It includes more than 32 million ratings given by around 2 lakh users for around 88,000 movies. Here we have two main tables. The first one is ratings. Each record contains a user ID, movie ID, rating, and a timestamp. The second table is the movies. Here, each record contains a movie ID, title, and the genre. I merged these two tables using the movie ID key, creating a single data set that links each user's rating to a movie title and genre. Next, I followed the knowledge discovery in databases process to analyze and prepare the data for modeling. The KDD process includes data selection, cleaning, transformation, data mining, and interpretation, and I applied each step systematically in this project. Like before merging the data sets, I performed data cleaning. I deleted few null values from the data. Then to make analysis computationally efficient, I worked with the 2 lakh row sample while ensuring diverse representation across genres. I converted timestamp column to date field, which helped in data analysis. I began my exploratory data analysis by studying how users rated movies overall. Here we can see a graph of rating distribution of different users and the average of the average of the ratings. I added a few more graphs here. Distribution of user rating counts, top 10 movies by average rating over the years, average rating by genre, movie popularity versus average rating. Then I moved to the unsupervised learning part of my project. Here I transformed the genre column into multiple binary columns using one hot encoding. These allowed me to represent each movie as a vector of genre categories such as action, drama, comedy, and science fiction. To explore patterns in user preferences, I created a user genre matrix. Then I applied k-means clustering to group users based on these genre preference. I used PCA to reduce I used PCA to reduce the high dimensional data to 2 dimensions so I could visualize the user clusters. The plot here shows 5 different clusters. Each color represents a group of users with similar taste. For example, one cluster prefers drama, one prefers action, one prefers adventure, etc. The Silhouette score was around 0.15, which is expected in real world preference data. Overall, this exploratory analysis helped me confirm that the dataset captures clear behavioral patterns that can be used for personalized recommendations. After completing data exploration, I moved on to the modeling and evaluation phase. I implemented and compared three main machine learning models for generating movie recommendations. The first one was user-based collaborative filtering. This model predicts a user rating for a movie based on ratings from the other users who have similar preference. I used the k nearest neighbors algorithm with 10 nearest users to compute predictions. Next one is item-based collaborative filtering. These model looks at similarities between movies rather than users. For example, if a user liked Inception, the system finds movies rated similar to Inception to many other users. The third one, which I used, is matrix factorization. I used this to decompose a large user movie rating matrix into a lat- latent features that represents hidden taste factors. Like this is normally used in organizations like Netflix. Then I used a comparison chart using a root mean squared error to measure how accurately each model predicted user ratings. As we can see in this comparison chart, item-based collaborative filtering model performed the best with an RMSE of 2.120, followed by user-based collaborative filtering with 2.692, and then followed by SVD with 3.264. These results confirm that users tend to rate similar movies consistently, making item-based approach both accurate and scalable for large data sets. Finally, I tested the best performing model, the item-based collaborative filtering, for a specific user, user 6574. As we can see in the table, the top recommendations for this user includes titles such as Clueless, Two Days in the Valley. These are all genre-aligned films, which matches with the user's historical preference. These confirms that the model has successfully learned user behavior patterns and can deliver meaningful personalized suggestions. To conclude, the item-based collaborative filtering model achieved the best performance, demonstrating accurate and stable predictions. The KDD process, from data cleaning and transformation to clustering, modeling, evaluation, allowed me to systematically extract insights and build a functioning recommendation engine. In the future, I plan to extend this project by integrating hybrid recommendation models, adding time-based features, and deploying it as a simple web application for real users. That's it for today. Thanks for watching my presentation.